what happened last time, but the video stopped recording when I was in the middle of this problem. So I will just pick it up in case this is where you're picking up the video. We have a problem. Y is less than or equal to the negative absolute value of x plus 2 plus 6. So that's our absolute value graph that we know, oops, is in the shape of a V. Okay, absolute value always has that general shape. We know that instead of starting at 0, 0, it's going to go left 2 and up 6, and it has a slope of plus or minus 1. Now, so when you plot that point, negative 2, 6, it would normally go up, but we have a negative sign out front of that, which flips it over the x-axis and makes it go down. So, in this case, and so that's our graph. So I filled that in while I was transitioning from one to the other. And now I have to figure out how to shade it. Okay, we always go to our y-intercept because we have y by itself on the left side. I can go to my y-intercept and I go back to my graph and that says less than or equal to. And so that means I'm going to shade those points that are less than. So that's on my graph. And as we talked about in class, let y equal to 0, solve for x and name the solution. But your solution is right here in front of you. So you don't have to do any math. You just have to know how to read the graph. This one crosses, that's supposed to be at 4. And this one, if that's negative 6, this is negative 7. So if you continued this out, then you would know that this point is actually negative 8 on the graph. And I'll make sure on the test that it won't run off and you'll be easily be able to see what those points are. But you can see on the x-axis, like we did on this one, okay, the x-axis part of the graph that's shaded is all of that between negative 8 and 4, okay? This is not two separate pieces, so this one says I can say give me those x values between negative x, excuse me, negative 8 and 4. And I look back at the original problem and see that there's an equals on there, so that means that I'm going to have an equals in my answer. So that's how you do those. All right, moving on to number 13. So in this particular problem, we are supposed to graph our system of inequalities. So hopefully, x is greater than 0. You know that this is the line x equals 0, and we're going to shade that way. Then we have y is greater than 0, which is my x-axis, and I'm going to shade up for that. Then I'm going to have x is equal to 4, and that will be a vertical line through 4, and I'll be less than, so I'm going to be shading that way. I'm going to put the lines on in just a second. Actually, I may put those on, and then I'll go do the rest of it. So I have x is greater than 0, and x equals 0 is this line right here. It is our y-axis. And as I said, we're shading that way. And then I have y is greater than 0, and that's going to be your x-axis. So it's looking like that. And then we have x is less than 4, another vertical line. Okay, x is less than 4 is going to cross the x-axis at 4, and so we're shading that way. And then the last one that I have is this one here. And this one we've talked about over and over again. Put those x and y intercepts. Find the x and y intercepts. So if you plug in 0, act like it's an equation because you're just graphing the line. Plug in 0 for x, and y has to be 9 because 2 times 9 is 18. If I plug in 0 for y, then x has to be 6 because 3 times 6 is 18. So we plot those 2 points. This is the point 0, 9, and this is the point 6, 0. So I'm going to go draw my line through those 2 points. And then I have to figure out where to shade, okay? And what we talked about shading was we plugged in the points 0, 0. So if we plug in 0, 0, 0, then this side becomes 0. Is 0 less than 18? And that answer is true, so I know that I'm going to shade this way. So, um, so I'm on the blue line this way, the purple line, the pink line, and hopefully y'all can see in that orange line that my shading is probably going to be a mess if I try to do it with this thing. Well, let's see how that goes. So I'm shading in here. And that one's a little bit tinier. So that is my shaded region right there. A little sloppy, but it's hard to do with the mouse. Okay, so I've graphed the system, and now I have to find the region. Okay, so to find the area of that region, okay, that's a trapezoid. Okay, if you can't see that, turn your head sideways. Okay, that shape is kind of looking like this. Okay, and so on my, oh, I didn't draw that very well to scale because this side, let's try that one more time. Because that one side is a lot shorter when I turn it sideways. So how about like that? So something like this. So this is 4, and this is 3, and this is 9. Okay. On here it looks like this. 4, excuse me, 9, 4, and this side is 3. So that's enough to find the area. The area of our shaded region is 1/2 the height times the sum of the bases. And I'm going to have to pause. So I will be right back. Okay, so to finish that, we have 1/2 the height times the sum of the bases. So you can see it this way, or you can look at the picture, but the height of my trapezoid is 4, and my bases are 9 and 3. So that is 1/2 times 4 times 9 plus 3, which is 12. And 1/2 of 4 times 12 is going to be 24. Area is always units squared. Okay. Now, I did mention in some of my classes, if you can't remember the area of a trapezoid, then you can remember to hopefully divide this into 2 parts. So this is one part, and that's another part. And when you do that, okay, part 1 has a shape of a triangle. Area is 1/2 the base times the height. Okay. And the base is 4, and the height is 6 because we're going from 3 to 9 on that one. And so that area for this one is 1/2 of 4 times 6 is 12. And then the second one is the area of a rectangle, which is length times width. And that, of course, is 4 times 3. And that one gives you an area of 12. And therefore, you would add those together and get 24. So you'll get the same answer. Doesn't matter which way you do it. Okay, find the perimeter. Okay, to find the perimeter of this, we have 3 and 4 and 9, but we have to find this piece right here. So to find that piece, you know, whether you look at it this way or whether you look at it that way doesn't really matter. Okay, but here's another triangle. Okay, and this side is 4 and this side is 6. So this side that we're missing is C. So we say that 4 squared plus 6 squared equals C squared. And 16 plus 36 is 52. So I'm going to take the square root of both sides. Okay, and when you do that, you got to break that up. 4 goes into it 13 times, and 4 is a perfect square. So we're going to find out that that C is equal to 2 square roots of 13. So when I'm finding my perimeter, which is the distance around, I'm going to have 3 plus 4 plus 9 plus 2 square roots of 13. And these are all like terms, so you would combine those and get 16 plus 2 square roots of 13. And that would be units. And that's squared because we're just talking about length. Okay? All right. Moving on. 2 more problems, then we're done. This is problem number 14. It says 16 on the graph, but yeah, you're supposed to use that graph for number 14. All right, so shade appropriately. So the first one says y is less than or equal to negative x plus 5. So hopefully you went and found y 5 on your y-axis, which that means that this has to be that line right there. So my red line is that one. It says y is less than that number, so I'm finding my y-intercept and I'm shading below. So that means that I'm going this way because I'm going to go less than on the y-axis. And that makes the other one with a y-intercept of 1 being this line right here. And it's greater than, so I'm going greater than this y-intercept, so I would be shading here. Okay? And then we still have our x and y. Oops, he didn't, I think it's the wrong thing. Okay. X is greater than 0 is going to be this right here, and y is greater than 0 is going to be that right there. And that, of course, doesn't affect because you can see that I have a bounded region. So my region is going to be this right here. Okay, so we shade this in. All right, that's part A. And now it says to name the vertices of the feasible region. So the vertices are those points, the corners of your shaded region. And from our graph, that gives us 0, 1, 0, 5, and 3, 2. Okay, we went over 3 and up 2. And so next, we're supposed to find the max and min values of the objective function and identify the corresponding x and y. So in this case, so at 0, 1, when I plug that in, there's my objective function that I'm plugging them into. Okay, that means that p is going to equal 4 times whatever x is plus 7 times whatever y is, and that's going to give me 7. And then I'm going to have 0, 5, and I'm going to plug that into the function, and p is going to equal 4 times whatever x is plus 7 times whatever y is. This is 0, that's 35. And then 3, 2, when I plug that in, p is going to equal 4 times 0. Nope, sorry, I got carried away. I thought I had another 0 point. 4 times 3 plus 7 times 2. And that's 12 plus 14, which is 26. So my answer is, which one of these is a maximum? And hopefully y'all can see that this is the maximum. So the maximum value is 35. Where does that occur? At the point 0, 5. The minimum value is 7, narrow, is 7, and that occurs at 0, 1. Okay, last problem, linear programming. And as I mentioned in classes, this is section 3.4 out of our textbook. There's a link on the calendar on the day that we first did linear programming that takes you to some extra practice problems on this if you want to, and it'll step you through how to do everything. So you can get to that on your Chromebook. Okay, so a doctor allots 15 minutes for routine visits, 45 minutes for physicals. I'm not going to read that because y'all have already read this. So the first problem says to define the two variables. Okay, so if you're defining the variables, y'all, you need to go see what is it asking, because the variables generally are going to help you answer the question. So how many routine office visits and full physicals should the doctor schedule to maximize her income for each day? So I'm going to have x equals, that doesn't say x, okay, um, x equals the number of, whatever you want to call it, let's call it routine visits. Routine visits. And y is going to equal the number of full physicals. So I'm answering the question. Okay, can either of these variables be negative? That answer is no. And so to write those inequalities, then x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Okay? Next, write an inequality to express the limitation of time. So when I'm looking at the time, this is my limit on time. The doctor only has 9 hours available. That's a limit on time. Okay? So there are two different ways of doing this, okay? But what y'all need to pay attention to, which is kind of like the sweatshirts and t-shirts problems we did when we talked about this the first time, is that this is in minutes. These are both in minutes, and this is in hours, and they all have to be the same. So you can either say 15x plus 45y is less than or equal to, these are minutes, So I have to change my 9 hours to minutes by multiplying it by 60, and that's going to be 540. Or you can write your minutes in terms of an hour, which is 15 minutes is a fourth of an hour, and 45 minutes is 3/4 of an hour, is less than or equal to 9. And the reason I say it doesn't matter, because both of them should be simplified. You would divide everything by 15 here, and you would multiply everything by 4 here to get rid of those fractions. So either way, it's going to give you with an equation that says x plus 3y is less than or equal to 36. So y'all aren't here to tell me when I write the wrong variable, but I noticed that that has an x in it, and that should be a y. Okay? So that is my limitation on time. Now, write an inequality to express the limitation on the number of visits. So where do we read a limitation? The doctor, the doctor cannot do more than 10 physicals a day. So which one is physicals is the y, and y has to be less than or equal to 10 because she can't do more than 10 a day. All right, and then we have our objective function, and our objective function is that function that we want to maximize or minimize. So in this case, we're maximizing income, and the income that she gets, okay, whether you write N or N, I or P for income, doesn't matter. She gets 60 times the number of routine physicals plus 100 times, routine visits, and 100 times the number of physicals. So my objective function is going to be 60x plus 100y. Okay, so we're going to go graph those, and one of the things that we've talked about in graphing a lot is in standard form, x and y are on the same side. Go use those intercepts. So if I put in 0 for x, then y is going to be 12 because 3 times 12 is 36. And if I put in 0 for y, x is going to be 36. So that is going to help us graph and know what our scale is. Okay, one more pause. Okay, so I'm back to finish. So the points that we had, oh, let's go see if I can look at those equations. We had x is greater than 0, y is greater than 0, and then we had the points 0, 12, 36, 0, and y is less than 10. Now, my x-axis has to be able to go up to 36, and my y-axis has to go up to 12. So I think what I figured out, okay, as we talked about that I can number this one by ones. 1, 2, 3, 4, 5, 6, 7, 10. So here's 10, 11, 12. So I have a point that was at 12, 0, 12. And then I have, this one needed to go by 2. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And that's 30, 32, 34, 36. So here's 36. So if I graph those lines, I had x and y greater than 0. So x is greater than 0. X equal to 0 is that line. Y equal to 0 is that line. Okay. I connect my two points to get that line. And that's right there. And then the last one is y equals 10. So that line is going to look like this through 10. Okay, so I'm going to pause because I don't want you to watch me shade everything. Actually, I guess we should talk about how to shade it. Oh, y'all can know. All right, so I'm going to go pause and shade, and I'll be right back. Okay, so the only thing we didn't talk about specifically before we go into that shading, you know how to do x is greater than 0, y is greater than 0, y is less than 10. But again, this one, we plug in 0, 0 for x and y, and 0 is less than 36, and that is a true statement. So when we come down to our graph, that is why we're shading the part that has 0, 0 in it. Okay, so moving on with that, we now have to go answer the questions. So we've shaded everything, and we have to answer the questions. So how do we answer those questions? We remember that the vertices of our shaded region are where we will maximize or minimize our objective function. So those are the points that are so important. So we start off with, we have 0, 0, we have 0, 10, we have 2, 4, 6, 10, and we have 36, 0. And I've got to put each of those into my objective function, which is 60x plus 100y. So when I go put in 0, 0, of course, that means that my profit is equal to 0, or my income. Okay? If I put in 0, 10, okay, then P is equal to 60 times 0 plus 100 times 10. And that is a total of $1,000. And if I go to the point 610, I'm having trouble with my arrows here. Okay, I'm plugging in 60 times x, which is 6, plus 100 times y, which is 10. So 360 plus 1,000 is 1,360. And then I'm going to plug in the last one, and P is equal to 60 times the x value of 36 plus 100 times the x value of 0, and that gives a total of 2160. So you can tell from that that the maximum income is right here. So which question answers what is the maximum income? That's the question for part B. So that's where I'm going to put 2160. And part A says how many routine visits and physicals. So the numbers that give me that are 360, and X is the number of routine visits. So 36 routine visits and 0 full physicals is how she will make the most money each day. All right, so review that. I hope that helps. If you have any questions, you can email me, come see me. Remember, the best way to study is to get a blank study guide. Work that study guide again, check your answers against the work copy, and if you still can't figure it out, listen to the video again. Um, Hope everybody does well, and come see me or email me if you have any questions. Thank you.